So now that we have a fairly good grasp of volume and surface area of three-dimensional solids or three-dimensional shapes, we're going to take it up another level. We're going to talk about volume of composite figures and then surface area of composite figures. So we're going to have to break these composite figures down into simpler shapes, more simple shapes, and basically because of what we've learned in this chapter, basically we're going to be breaking it into prisms and pyramids. In this first example here, we have this kind of L-shaped solid, and we're going to cut it into two pieces. We're going to cut it into a longer rectangular prism and that little short cube there. Actually, it's not a cube because of this dimension here of 6. So it's going to be difficult to break these up in our head, figure out like missing dimensions, and it's going to take a lot of effort, a lot of focus, and a lot of practice. Now, we don't have a ton of time for practice. Sorry, I can't draw very well with this trackpad, but anyway, this is how the book cut it. You could also cut it your own way. For instance, you could cut this bottom part off and have this long rectangular prism on top. But to find volume, we're going to be using our volume formulas. Now, this is one way to write the volume formula. The other way that we've talked about doing it is instead of this length and width here, we've done the big B, right? Capital B, which means just the area of the base, which the base here that we could talk about is this 8 by 6. Okay, that 8 by 6 there, and then you just multiply it by the height. So volume of any prism can be found as the area of the base times the height. So I just like that because it gives you a formula for all prisms as long as you can identify what a prism is. So anyway, all we have to do is find the volume of the individual solids and then add them up at the end and get the volume of this composite solid. That sounds simple when I say it like that, but the breaking up and finding the individual, all these dimensions, that can be very tricky. A good example of that is right here, where this smaller rectangular prism up here, it tells you that you have a dimension of 6, you have a dimension of 8. So what's that third dimension you need? Well, that's kind of going front to back. That's going bottom to top. So what we need is the left to right dimension, the third dimension. And we could say that that would be right here. All right, well, what is that though? It doesn't label it, doesn't label it up here, doesn't label it down here. How are we going to get that dimension? All right, well, this goes back to when we're doing composite solids and figuring out missing dimensions or missing lengths. So we have to look at all of the other lines that are going in this same direction. All right, so that would be this 8 here and then this here, which we can match that up with this back one, which is 16. So we have this front line, which is 16, this bottom line, which is 8. So it looks like this line should be whatever we'll add to 8 to get this full length of 16. So that would have to be 8 as well. All right, so it can be tricky. You can see how that can be tricky with all my scribbling around here to figure out what that missing dimension is. But you need those 3 dimensions of a rectangular prism so you can plug it into our formula and get the volume. All right, so the overall gist, the overall summary, break it up, find the volume of each individual shape, then add those volumes up to get the volume of the composite figure. Whew, it's going to take some practice. There's going to be times where you do all this work and then you think you did everything perfectly. You're like, yes, I finally get it. And then you're going to get this answer that's not even close to the right answer, or that's a little bit off, or it's just wrong. Your answer's wrong. And you're like, I thought I got it. But you're closer than you think. All right. All it takes is one number that you plug in and get wrong, and it makes you feel like you don't get any of it. But hang in there. And I'm guaranteeing that if you hang in there and keep practicing, you'll get better at it. These ones are hard for me. I mean, I'm not perfect at it, and I'll make little mistakes, and I'll be like, "What? Where did I go wrong? I swear I did it right." And then I'll say, oh, that's the problem. Okay, so let's check this next problem out and start getting our practice on. All right, you can see that this solid, this composite solid here, was broken up into two figures. We have a rectangular pyramid, so, right, rectangular prism, right? What's the difference between prisms and pyramids? Prisms have two bases, and a pyramid has one base, all right? So we have this prism over here and this pyramid right here, and it looks like so once we break it up, we indicate what shape it is, then we can find the appropriate formula for that shape. Here, I like to use BH for prisms, but for rectangular prisms specifically, only rectangular prisms, you can use the LWH formula. But I like this as a general way to do prisms. The formula for a pyramid is volume equals 1/3 capital BH, where capital B is the area of the base. Okay, so we break it up and then we plug in the appropriate dimensions. Nice that we have the length, width, and height all given to us. Now, for this pyramid up top, it does not label the dimensions of the base, so we'll have to look at the other part. So since this right here is 8, that means that this is 8. Since this down here is 8, that means that this is 8. All right, so now we have a good indication of what all of our dimensions are, and we struggled with this formula in the past. Hopefully we can get the hang of it now. The base is a square, so we're going to use length times width in there. I like to do that over here as opposed to doing it right in the formula. So I look at the base of that pyramid is a rectangle, so I'm going to do the dimensions times each other, 8 times 8. And then I plug in a 64 right in here because I already did my work over here. All right, I like to do the big B, and when we did surface area of pyramids, I like that. Remember the capital P? I like to do that off to the side so it doesn't confuse my work over here. All right, and then you just multiply all these together, calculator, get the answers, and add them up. Okay, so challenging, but we can do it. I know it. All right, try this guy today, and then this lesson will be done. Try it, and then I'll show you the work. Okay. Oh, actually, don't pause yet. Look here. I'm going to cut it here and here. So we have that big guy, and then I'm going to cut it right there. So I'll have these two thin rectangular prisms, and then this a little bit thicker rectangular prism up here. So anyway, you do it that way as well, so we can kind of have the same method to check each other on. All right, pause, try it. Good luck. All right, so I'm going to do my work over to the left as usual. I have those thin guys, which look like that. All right, if you're not very good at drawing, it's okay. Just sketch it out as best you can. And it looks like that is 1 centimeter across, a depth of 6, and a height there of 7. All right, and it looks like both are exactly the same, so I'm just going to get that volume and times it by 2 once I get it. And my other one is that thicker rectangular prism like that. It looks like all the way across is 12. Ooh, it does not tell me this dimension here. It does not. So look over here. It looks like, I'm going to change colors. All right, it looks like all the way top to bottom of the shape is 9. It looks like part of the way up is 7. So therefore, 7 plus what is 9? 7 plus 2. So that little dimension there that I'm missing is going to be over here on my drawing, or sorry, over here is 2. All right, now how far back does this shape go? Well, if I look back over in the book, I see that I'm going to go with a different color. Okay, it looks like it goes back that far, so that dimension there is going to be 6. All right, now I need, excuse me, I should have actually already written down my formulas because my formulas will determine which dimensions I need. So I jumped ahead a little bit there. Sorry about that. Let's get our formulas going. So these are rectangular prisms. So there we have that, and there we have that. Now, volume equals. Now, the base of this, let's call that guy the base. All right, because he has a matching base way up there. All right, so big B for that is going to be 6 times 1, so that's 6. So the base is 6. The area of the base is 6 times the height, which connects the two bases, is 7. So that gives me 42. And then I'm going to multiply that by 2. Why? Because there's a kind of the leg of the table and the leg of the table over here. So that gives me 84. Now, let's find the volume of that other, the tabletop, basically. All right. Big B, I'm going to call kind of that the base down there. And so that's going to be 6 by 12. Which gives me 72. So replace that with big B, and the height there is 2. So that gives me 144. And now I have 84 plus the 144. Gives me a grand total of 228. Let's see if we got that. Boom, 228. And I did not label with cubic units. Cubic. 3 dimensions. All right, let's turn those numbers off. So let me know if you had trouble with that. Try to find your mistake. Remember, you could have also done volume equal length width height because it's a rectangular prism. Don't try it on a triangular prism. That's what people are getting messed up on. And don't try it ever on a on any pyramids. All right, where you could have done length width height and gotten what are the dimensions? 6 times 1 times 7. Right, and this one would be length times width times height, so that would be 6 times 12 times 2, and progress from there. Okay, all right, hopefully you guys are on it, and we are finished with this part of the lesson. All right, these can be challenging for sure. Let me know if you have any questions, and we'll try to work them out.